The following question reads that sulfur dioxide is used in as a preservative in winemaking. And the following equation describe how sulfur dioxide dissolves. So the two equations given where H2O first reacts with SO2 to produce HSO3 minus ion plus H plus 1 ion, and in the second step HSO3 minus 1 combines with the H plus 1 to give you SO3 2 minus plus 2H plus 1. Now the question is about which statement about these two reactions is correct, and the first statement is HSO3 minus 1 ion acts as a base. Remember, a base is a substance that accepts H plus ions. So we need to figure out whether HSO3 minus 1 is accepting H plus 1 ions. If you look at this equation, this first reaction, this is HSO3 minus 1, and if you look at the backward reaction, you would notice that HSO3 minus 1 is accepting an H plus 1 ion, or in other words, HSO3 minus 1 ion is producing OH ions. Now, whenever a base produces OH ions, those OH ions accept H plus 1 ions. So indirectly, anything that produces OH minus 1, according to Bronsted-Lowry, is also a base because it's capable of accepting H plus 1 ion. So OH minus 1 accepts H plus 1 ion to produce a water molecule. So it's a neutralization reaction, and this is accepting an H plus 1. So HSO3 minus 1 ion acts as a base in one of the reactions, because if you look at the other reaction, you would notice that it's acting as an acid, because if you look at the second reaction, HSO3 minus 1, on the other side it produces another H plus 1. So initially you had one H plus 1, now you have two H plus 1 ions. So in this second reaction, HSO3 minus 1 ion is acting as an acid. So the question was which statement of these two reactions is correct. So HSO3 minus 1 ion acts as a base is correct for one reaction, but not for the other reaction. Let's look at the second statement. SO2 acts as an oxidizing agent. For it to act as an oxidizing agent, it needs to be reduced. Now, if I look at SO2 in the first equation, you will notice SO2 gets converted into HSO3 minus ion. So the conversion is SO2 gets converted to HSO3 minus in the first reaction. Now, for it to act as an oxidizing agent, it must get reduced. The oxidation state of sulfur over here is +4 because oxygen is -2, and over here sulfur is again +4 because oxygen is -6. Then you have 1H, which is +1. That would give you -5. Then it has a minus charge, so S must be +4. So no oxidation or reduction is happening. The same is the case with the second equation, where HSO3 minus 1, there is actually no SO2, so we don't need to be concerned with that. The second statement is definitely wrong. If you look at this third statement, option C, it says SO3 minus 1 acts as an acid. An acid is a substance that produces H plus 1 ions. So for it to act as an acid, it must produce H plus 1 ions. So SO3 minus 1 is present over here. So for it to act as an acid, if you look at the reverse reaction, it must be capable of producing an H plus 1 ion, but it's not doing that. It's actually accepting H plus 1 ion, which is why it's acting as a base. So this option C is also incorrect. It's not acting as an acid, it's acting as a base. The last one is that SO3 2 minus acts as a reducing agent, which is also incorrect. We've already figured this out, that there is no reduction or oxidation happening. It's not a redox reaction. Both of these reactions, there is no change in oxidation state. So whether you're talking about oxidizing agent or reducing agent, the terms do not apply, because if it's a reducing agent, it must get oxidized. But there is no redox reaction happening. So option D is definitely incorrect as well. So you're only left with option A, which was partially correct, that HSO3 minus 1 acts as a base. Now in the first reaction, it is acting as a base. So option A is the only option left, and that's your correct option.